Due to our change in schedule now, we are not doing a new lesson today with our virtual practice day. Instead, we are continuing to review to get ready for the test that we are now planning to have on Friday so that you guys can get Appendix 5, Appendix 6 tests done before going off to Thanksgiving break. With that said, we are doing a review lesson specifically on the questions on number 2 on the review. Meaning if you look at number 2, you've got an A, B, C, and D part. I'm going to try and review that lesson a little bit to help with that because I think that's the lesson of all the things that we're testing over. It seems like that's the one that's given the majority of you the most trouble. And so I thought if I could review it with this, then maybe that would help and then we'd get more ready for the test. Okay? We are talking about solving rational equations. That's what number 2 is covering. When you see the word rational, we are talking about fractions, right? Which is obvious here from the example. I do want to remind real quick, this is a video, so if I go faster than what you can handle, do remember you can always pause it, you can back it up, that sort of thing, right? I'm going to try, I may go a little bit faster than necessary just because I don't want to have a whole bunch of lag on this. So, when we're dealing with fractions, and more importantly, not just fractions, but we are adding here. And anytime we are adding or subtracting with fractions, the number one thing we need is a common denominator. If we can get this whole equation, all three of these fractions, to have the same denominator, then we can just solve out the numerators, the tops, and call it good, which would make this a lot easier for us. In order to get a common denominator, the first thing we need to do is to make sure every denominator is fully factored. Now, first fraction, I don't think there's too much to be done with that. I think we can all tell that's definitely factored. Looking at our second fraction though, v squared minus 5v, there is two terms there, and they do both have a v in common. So it would be better for us to factor this so that we still have 1 over v, but for our second fraction, instead of writing the denominator, the bottom, as v squared minus 5v, let's pull a v out and make this v minus 5 left over inside. And then we do have the same denominator in our third fraction, right? V squared minus 5v, so we ought to do the same thing with that. Do notice I am not changing the numerator whatsoever. All we're doing is factoring out the denominators, only the bottoms. Okay? Now the reason why we're doing that is because when we factor this, what I would like you to notice when we are looking for a common denominator, every single one of these fractions has a standalone v, just a single v. Those are all in common, which means I don't need to worry about that. That's already taken care of. Now the problem, as you may notice, is this fraction has a v minus 5. This fraction has a v minus 5, but our first fraction does not. So in order to get a common denominator here that will allow us to just be able to solve the tops, just solve the numerators, we would need to make sure that first fraction becomes common. Well, that's pretty easy when we put it this way. All it's missing is a v minus 5. So let's take 1 over v and multiply it by v minus 5. But obviously we can't just multiply the denominator by v minus 5. That means we have to multiply the numerator by the exact same thing to keep this all equal. In this case, it is just 1 on top, so 1 times v minus 5 is v minus 5. I do want to point out, if this was any other number, do recognize this is a distributive property. So like if that was 2, you'd be taking 2 times v and 2 times negative 5, right? But we don't really have to worry about that here because 1 times anything is 1. So now we've got v minus 5 over v and v minus 5. Now we have both parts of our denominator in the same fraction. So now I'm just going to rewrite the other two fractions. 3v plus 12 over v times v minus 5 equals 7v minus 56 over v times v minus 5. And now when we look at this, we can visually see all three of these fractions have a standalone v and v minus 5 as a quantity. And since all three of those have exactly the same denominators, we can now just completely ignore those and just solve out the numerator. The idea with that is we're multiplying the entire equation by v and v minus 5 and canceling it out. So right now, we are sitting at v minus 5 plus 3v plus 12 equals 7v minus 56. Now that is a lot of stuff, but it's certainly something we are capable of solving now. Remember, our goal is we want to get all of our v terms on one side and all of our constant terms on the other side. For me, I would prefer to simplify all my like terms on the same side, so I'm going to take v plus 3v to give me 4v, and then I'm also going to take negative 5 plus 12 to give me 7. And then I'll go from there. Now I want to get all my v's on one side, all my constants on the other. It's kind of up to you guys which direction you want to go. It truly doesn't matter whether you get all your v's on the left side or the right side, and same with the constants. For me, I'm going to put my v's on the left and my constants on the right. So I'm going to subtract 7v to the left side. 4 minus 7 would give us a negative 3v plus 7 equals negative 56. Then I'm going to subtract 7 to the right side, giving me negative 3v equals negative 56 minus 7. Those are both negative, so this would be a negative 63 that I'm taking. And then finally, I'm going to take negative 3 and divide that over to the other side. First off, negative divided by a negative is going to be a positive, so do recognize that. That is important. And then besides that, 63 divided by 3 is going to give us 21. And that would be our answer for this problem.